let's continue 5.2 together. So now that you have practiced finding critical numbers, we're going to analyze these functions in the interval that's given to find their critical numbers and to evaluate their endpoints, and then to find their absolute max and min values according to the value of the critical numbers and the endpoints. Okay, and we're going to do this all without graphing. Although, to be honest, I really do like using Desmos, and it's a great way to check. So maybe we'll graph a little bit. Okay, let's look at number 3 here. We're given the function y equals x minus 3. The steps are on the side here. Number 1, find the critical numbers. Number 2, evaluate the function at each critical number. And number 3, evaluate the function at each endpoint. So step 1, find the critical numbers. We know that critical numbers happen when the derivative equals 0 or the derivative does not exist. So when will that happen? Okay, the derivative of our function, I'll write it here, y prime is going to equal 1. All right, so when does the derivative equal 0? Never. And are there any places where the derivative does not exist? Nope, none. Okay, therefore there's no critical numbers, which helps us with step 2 because evaluate the critical numbers, there are none, so we don't need to do anything. Number 3 is to evaluate the functions at the endpoints. So we can see the endpoint is 0 and 6. So let's do that. Y equals, x is going to equal 0 minus 3. And y in this case equals negative 3 at that endpoint. At the other endpoint, the function is y equals x, and in this case 6 minus 3. At that other endpoint on the right, we will see that y is equal to 3. Okay, so the maximum of this function, well, it looks like our max will be y equals 3. And the minimum, absolute minimum, negative 3. Let's move on to the next one. Okay, so we're looking for the absolute min and max without graphing this function. Step 1 is to find their critical numbers. We know we do that by using the derivative, so let's find the derivative. 2x minus 4. Okay, critical numbers we know happen when the derivative is equal to 0 or when the derivative does not exist. So when will this derivative be 0? Well, 2x minus 4. If I solve here, that's an x. If I bring the 4 over, divide by 2. Okay, there's one critical number. Now, does this ever not exist? Meaning, is there any asymptotes here? Things that are not in the domain? No. Never. It always exists. Okay, so we have a critical number. Step 2, we're supposed to evaluate the function at that critical number. We know that critical numbers are the places where the tangent has a slope of 0. That's what we just figured out. Places where tangents have slopes of 0 are going to be the spots on the graph where the slope or the direction turns from positive to negative or negative to positive. So we know that's a critical number, a high or a low point. Let's find out the value. So if we put a 2 in to the function, let's see what we get. We'll get 2 squared minus 8 is minus 4 minus 1 is negative 5. Okay, so that's going to be 1. That's a possible absolute max or absolute min. Let's do the last step and find out what the min and max is at the endpoints. So we look at the endpoints here. The first one is the 1. let's put a 1 in for x. 1 squared minus 4 times 1 minus 1 will be minus 4. And the other endpoint, positive 4, should yield, let's see, 16 minus 16 minus 1. Okay, so here's our three possibilities for mins and max of the function. It appears like minus 5 is the lowest. This is the absolute minimum. And minus 1 is the highest. This would be the absolute maximum. Okay, now I did look on Desmos here. And this is the graph that we see of this parabola. And the highlighted part is the interval we're looking at, from 1 to 4. Now when I do that, when I look at where it hits 1 here, that's the endpoint negative 4, which is what we got. At 2, that's at the critical number that we found. The low spot, and it is an absolute low, is minus 5. And the other endpoint, when x is 4, is negative 1. So our work is correct as shown by the graph. We're going to omit C, and let's flip to the next page. So we're looking for the absolute minimum and the absolute maximum of this function here over this interval between 2 and 4. Right away when we look at it, we do see that there's a restriction on the domain. We see that x cannot equal 1. Okay, so the first step is to look for the critical numbers, and we know that we need to know the derivative in order to find the critical numbers. So let's go through that. I'm going to pause it. You're going to find the derivative of this function. You need to use the quotient rule. Here's what I've got so far. Again, you can pause that, and we're going to multiply everything through and gather like terms. Alright, when the like terms are gathered, we find that the derivative is this, x minus 3 times x plus 1 divided by x minus 1 squared. Now we know the critical numbers come from wherever the derivative is equal to 0, or where the derivative does not exist. Okay, so where the derivative is equal to 0, well, here's the derivative. We can probably look at it and see the zeros. If you cross multiply here, the denominator is multiplied by 0, and then the two factors will be our zeros. So we can see right away that if x is 3, this first factor will evaluate to 0, or if x is minus 1. Okay, so x minus 3, yes, it's in the interval. Here's one of our possible critical numbers. We can see that x minus 1 already is not in the interval. You can leave a little note so you remember what happened there into that one. That is not a possibility. Okay, let's look at the places where this derivative does not exist. If we look at the denominator here, we can see that this derivative, were we to graph it, would have an asymptote at 1. Okay, it does not exist at 1. So we see here that x equaling 1 is also, a critical number. Now, although we look up here and we see in the original function that negative or positive 1 is not in the domain. There's this restriction here. So this is not in domain, and therefore it is not included as a critical number. So we've got one critical number at x equals 3. So our number 2 here, to evaluate the function at that critical number, will evaluate to 8. Okay, and step number 3, I'll move over here, is to evaluate the function at the two endpoints. So our left endpoint is at 2. So I'm going to pause it, and you can do those two endpoints. Alright, so after evaluating at the two endpoints, at 2 and at 4, we have these three possibilities for the absolute min and max of the function. We can see that 9 is the biggest. This is the absolute max of the function, and the smallest would be here, the absolute minimum of the function. Now remember that the absolute minimum is 8, and it happens at 3. The absolute maximum is 9, and it happens at x equaling 2. Okay, you can proceed to your very short end of this assignment. Unfortunately, 5.2 has been more me instructing than you actually working. But hopefully you've caught on to these 3 steps to finding absolute min and max.